support on your laptop today. I think we still have maybe a minute. Any questions before we get started for like organizationally? Yes? Okay, so Anaconda 3 is just Python 3?
Yeah.
Okay, so everything we do is Python 3 because we believe in the future. But I'm sorry, I don't work for one of those companies. But yeah, but you can pick. Anaconda 2 is Python 2, Anaconda 3 is Python 3. Both will basically, like everything we do today works on both, as long as you're Python 2.7 reasonably up to date. So, although we didn't put in all the funky print functions and things like that, so, but whatever. Cool. So why don't we just go ahead and get started? Are we ready? Awesome. Welcome everybody. This is PyData 101. So this is a novice introduction to the tools that what people who come around and say PyData, we're just going to go through a few tools and kind of get people started. Like the thing you need to know to just like start grokking like PyData tutorials. Okay, so this is supposed to be very novice. How many people are novices? Awesome. You guys, make a friend. Okay. So in fact, I would even encourage you to move to somebody who didn't raise their hand. So let's raise your hand if you're a novice again. Okay, so these are the people we need to help and make sure that they don't get stuck, okay? So I want everybody to first off, let's stand up. Let's stand up. You guys are not talking to me, so let's stand up. Stand up. I'm going to invoke RMS. The first thing we do is we stretch. We stretch. We go down. Oh. We jump. We jump. Okay, a few people are jumping. Awesome. Now you get out your wallets and give me $1,000. No one did that one. But yeah, so talk to your neighbors. Say hi. Everybody say hi to your neighbor. Maybe say what your name is, where you're from. Awesome. So now you just met your best tool at debugging whatever goes wrong on your computer, your neighbor. There's two of us, and we're happy to run around and help, but definitely feel free to ask your neighbor. So my name is Andy Terrel. I'm a CTO over at Fashion Metric, which is a company that runs data analytics for retail apparel space.
Yeah. I'm Christine Doig. I'm a senior data scientist at Continuum Analytics, the company that develops Anaconda.
So, and what we both have been working in the PyData ecosystem for a while, and so we really enjoy like the tools that are there. And so this is kind of our kind of exposition of kind of the tools of getting started. So first question, how many people have Anaconda and the repo working on their laptop? Okay, good, awesome. That is like the best I've ever seen. You guys get a high five. Awesome. How many people are going to use Binder, like and launch a Docker instance? Awesome, a few of you guys. Cool. So if anything goes wrong and things don't work, feel free to hit on Binder and come back. So with that said, and let's make sure, and once again, you need to chat, you can come in and pose questions. Okay, so this idea here behind the chat is I will switch over to it every once in a while, and people can ask questions like, let's see. So there's your first question. Who knows about pandas? So anybody who's like says they're a pandas expert, like go in and write your name, say hello, so we all can like point to people. All right, cool. So those are a few of the housekeeping to get up to date. So let's go ahead and start the exercises. So when you launch, so just if you're in, start from the actual start, right? So we're running a product called Jupyter. So what you do is you go into your, So we go into my PyData 101 repo, and I type Jupyter spelled with a Y because it's Python. And we've typed notebook. Okay? So if you have Anaconda and you have you're running locally, go to a terminal, type Jupyter Notebook, you hit enter, and what it's going to do is it's going to start up a Python kernel in the back, and it's going to pop up this guy, which looks exactly like the contents of that repo. Inside this repo, we have our notebooks. So these 0, 1, 2, 3 is our prepared discussions. The way we were going to handle this is we have a few prepared talks. Then we have examples, which are just me hacking, basically, of like different ideas about like data. Like we do data science, very exploratory kind of munging thing. And so we thought if we just gave you talks, you would learn nothing. So we have some examples of me just kind of going through, hey, what can I do with this piece of data? And we have Amazon reviews, some baseball statistics, some old Boston housing data, and some scikit-learn examples that you can pull straight from the repo that help do like beyond. So you can kind of take whichever your heart desires and learn from different pieces. I guess if you're brand new, if you've never touched any Python or PyData tools, start with the Boston housing data, but we'll do that. We'll get into that later. Let's go through but we have fresh notebooks here, so you can like just pull up an exercise and start hacking with them. And any one of these, you pull up, and we tell you how to load the data and a little bit about the data, and then give you a blank case. Okay, so that's the repo. We have a few other things in there that we don't really need to go into too many details. So the data is all in data. There's a cheat sheet that I thought was kind of interesting of people like basic commands to use. The environment.yaml is for the Anaconda. If you are a person who's an advanced person in using Conda and Anaconda, and you want to learn about that, just ask me later. But I don't want to go into like all the pieces there. And some resources where we picked up different pieces. So no further ado, let's start with the intro. So this is a Jupyter notebook. It is an executable document. The idea is that you can edit cells. So if I hit enter on this cell, I go into a markdown cell. And this markdown cell, I hit shift enter, and it renders it for me. There are different types of cells. But here are, like, I'll get to the different types of cells and how to use them a little bit more later. But just remember, enter to edit a cell, shift enter to execute the cell. So today we're going to go doing an intro now. We're going to start with pandas, then do exploratory visualization with bouquet, and then do a little bit of data modeling with scikit-learn. Scikit-learn, like we are probably going to just like dip our toe in the water. And there are some excellent tutorials and talks at the conference to go see, and like the people who wrote scikit-learn and really understand it all the way through. We understand it, but we just didn't want to go too deep. I think I've gone through all this. So any questions of, like, everybody's set up, they have something they can start running somewhere. Anybody not set up? Okay. Does someone have a USB? Awesome. Maybe, Christine, you could help this person, these two guys over there. Awesome. Yes, are you? No, because there's umpteen dozen computers, and so I wasn't able, I didn't want to put, I literally calculated out it's a combinatorics of like 15. I'm like, I don't know. I don't have room for these things. These are cheap USBs that I can throw away, so. Okay. All right, so let's start. I'm going to just go through the tools that we're going to use today and give you a brief intro to what they are and where you find more details about them. So the first one is Jupyter. And so one of the nice features of Jupyter is let's see what they call it. An open source interactive data science and scientific computing. One, they have IDEs like this notebook, and two, they have consoles. I think if you ever used IPython, it stood for Interactive Python, wasn't the very first thing they wrote, which is kind of a shell wrapper around the Python interpreter that did things like autocomplete and other little nice features. Well, it's grown up now, and it's a huge ecosystem, and you see it embedded in, like, for example, if you go to Microsoft Azure ML, you'll get a Python doc. If you go to Domino Data Labs, you'll get a Python notebook. If you go to IBM's analytics cluster, they'll have Spark with a Jupyter notebook. So all of these places have started to adopt this, and even the Apache, there's Apache Zenith ripping off the notebook, so there's an Apache approved version 2 out there. There's other kind of things like it. There's Beaker, a few others. So there's lots of notebooks. So this idea of a notebook to execute and see code and do your analytics. So you have code plus documentation right there. And so kind of a riff on Donald Knuth's literate programming from the day. And so this is the first tool, pretty much we always use, and I'll show a few reasons why a little bit later, some really cool features. I actually grew up not as somebody doing kind of more standard on a console and things like that, but now I use Jupyter almost exclusively. So the second tool in our toolbox is a tool called Pandas. I think Pandas originally stood for panel data structure, but it's I don't think that many people use the panels. At least we're not going to get into the panels right now. The thing that it gives us, the biggest piece, is a data structure called a data frame, which is a easy-to-use data analytics structure that basically you get your data into a data frame and you can do a lot of analytic tricks with it. And so so if you've ever used R is built around a data frame. And if you ever want to say, people say, oh, I want to use Python, and from the R world, stick them to Pandas very quickly. Pandas has a little bit of a learning curve. It's one of those things that you can get something up really quickly, but it's got a lot of depth to it, so there's a lot of things that people do. I guarantee you that I've used Pandas for 10 years now, and there's things I don't know. So it's definitely a tool that has a lot of different use cases, but it's become the de facto tool for pretty much all Python data analytics at the exploratory stage and so on. So definitely a tool to be able to use and well. The second tool is a tool that's newer, and it's called Bouquet, actually, if you ask the person who named it, he would tell you to go find a Japanese person and figure out how to say bouquet. I say bouquet, some people say bouquet, I don't know. Any Japanese people in the room? How do you say it? Bouquet. Is that right? Yeah, okay, bouquet. There we go. I'm probably not going to adopt that one. I'm going to anglicize it. So, but bouquet is what it means is it's a photography, in the US at least, it's a photography term for you take a picture and you have that blur on the outside. And so the idea being you focus on one thing and you blur out what's not important. And that's what you do with your data analytics, your visualization, is that you want to go focus on a few things that are very important that you want to learn, and you want to get all the other details out of the way. And so it's an exploratory, I like to call it an interactive. So they say interactive visualization library. I say kind of an exploratory data analysis platform. Exploratory data analysis is an academically approved term, so you can go Google it. It's cool. And so this is the tool we'll use. There's other visualization tools, and you can go. I don't know if there's this conference, but there's many conferences. You'll see 10 ways to view your data, to visualize your data. Bouquet is only one of them. So we're only going to use one tool today, but don't think this is the only tool in your toolbox you'll ever use. I mean, there's lots of visualization tools that are really awesome. The last one that we're going to introduce, and so in 3 tools, 3 hours, it's going to be awesome, is scikit-learn. So scikit-learn is become the de facto machine learning interface for Python. And what I would say here is like it's the first thing you kind of like dive in because it's written very well. It's written by some academics out of INRIA, Gaël Varcroix and Olivier Grizel, and they've like really focused on making it simple to use so you can get up and get started. Now, with that said, like whenever you use a library like this, it's leveraged on like, 150 years of mathematics. So it's definitely a lot of like deep things going on under the hood, and we're not going to get into any of that. And so there's a lot of people who talk about using a different tool here and there, like Dayano is a good tool, Lasagna, PyLearn 2. There's lots of other tools out there that take a little different take to all the different pieces of the modeling. Scikit-learn is like the one that people always start with. And pretty much almost every tool these days has an interface that looks like scikit-learn. So it's a good interface to learn. Awesome. And that is a bug, and this is the beauty of, oh no, that's okay, that's the web page. I was like, what is going on? So here they talk a little bit about their tool. Okay, cool. So those are the tools we're going to use, pandas, bouquet, scikit-learn, to do data analysis and build these things out. I think I've gone through the installation piece enough. So okay, so I hit enter a few times, and so if you just hit Shift Enter a few times, you get these nice cells. What these cells are is an line at the interpreter. And so I can say all sorts of fun things like, print foo. And I get right out of the bat my data. If I say, so this is Python 3, awesome. I'm actually don't use Python 3 every day, so I have to learn some of the tools here. So what will happen here is if you get something that's like too much to digest, it does some things for you to make it easier to digest, right? You can say, oh, I want to see the whole thing. I click over here and I get out of the way, or I can click somewhere and get it to go away completely. So first off, it has a really rich kind of visual system. And you will see as we get into these tools how much easier it is to visualize what's going on. Probably the tool that I love the best, so there's this whole idea of like magic. I think you do %%, and it gives you, no, it's a percent. Okay, so one thing you can do is it has a really nice pager. If you ever have a question, you just type something and type a question mark, and it tells you the type signature. So instantly, as you're learning tools, you can just type a question mark and see what the doc string is. Now, it didn't write the doc strings for every Python tool out there, so sometimes the doc strings aren't very helpful, but we're getting there. So that's one of the critical features I think a lot of people will find useful. The one that I really love is if you write something like, let's say hello. I write a function, and this function has a bug in it. I say, for example, print Python 3 is not here. I write this guy. Well, okay, that's a syntax error, so that's not going to help. So let's do something here. So it's a good error. Let's say foo equals bar, right? So I have this function, and if I run my hello function, I should get an error if I actually call it. It's really awkward, like typing down like this. So you see you have some error there. I do %debug, and I'm instantly put into the context for which that error happened. So this is a feature. I like to show this feature off because this is a feature I use almost every day. Whenever I have a piece of code that's going bad and I need to run a debugger really quick, I can run a function here, and I can then, play with it, right? So something like that, So you can actually get an interpreter at the debug stage. So for novices, whenever there's something that goes wrong, and you're like, what you'll see is these tools are built on large stacks, and being able to get in the debug and go back to the context which called it is really, really quite awesome. Yeah, C, so it's just the Python debugger. So C was actually continue. So what it did is it just went and continued, and then the next instruction was return, so then it closed. Q is actually quit and get out. Okay, so that's if you've not touched the Python debugger before, it is an awesome tool. I really recommend using it. You will never use a print statement again. Another function I use a lot is there's time it. So if you ever sit around and have those discussions like which is faster, man, like a list comprehension or a range query or something, right? So say for I in range 100. So yeah, if I can type. So time it. Well, let's see here. We don't want all that output. So I timed it and it didn't spit things out. I always hate it when these things don't work. There we go. So if I do time, it tells me exactly how much something took to run. So then you take that same idea and say, okay, which is faster? Can I just call list? Now this is a really stupid example, but I just wanted to show a few things of what people do. And you see, instantly you can tell that, hey, actually, maybe there is something to say that the list comprehensions are really fast. But let's not dive into that too much. So time, I think I think I used time it wrong. If you do time it, it's % time it, and then just the same line. And so this actually will go and run, time it will run it a few times, figure out how many times it should run it, and give you a statistical average. So it's a little bit better than that time function. So if I do the same thing here. So someone's asking about multi-line. So if you want to do a multi-line one, just make it into a function. 2% so I can do multi-line? Oh, awesome. This is why I do this, so I learn new things. So we can come back and say, well, maybe the list is actually not faster because we statistically ran 100,000 times or something. So another thing to run, so you can do, if you do a bang, I get to a shell. So if I say cat print, or let's see, echo print. So if I run that, it actually ran it on the shell. And if I type ls, I'll actually see it. I see my.py, and then %run my.py. And this will run that piece of code as if it were in the interpreter. So that was a really simple thing. But if you have, for example, a very long script, you want to run your tests, right? I do %run, I'll run inside Jupyter Notebook, and then I can then do %debug and go to exactly where my error was. So this is like that iterative kind of like when things go wrong type thing, which is really handy in Python because sometimes you need to get down to exactly what the types are. Okay, so that's my intro to Jupyter. There's a lot more things in there. Remember Shift-Enter. Oh, there's also, I said I promised which type of cell things are. And now I have to remember how to, how do I change the cell? Okay, so I know how to do it through the help menu. So the help menu, so the other thing about this is there's a nice user interface tour. You should probably go through that. But there's a keyboard shortcut mode, and you have command mode, so if I escape, I can use these hotkeys. But I should be able to change, here we go, cell type. So you can see your cell types, you have code. If I want to actually make that into a markdown, I hit markdown, and then I can edit markdown. And so, and like any sort of like markdown kind of works. I forget the flavor they use, but you can kind of look it up. The other thing you do, if I hit escape here, I hit M, I get my markdown. But if you look at that escape mode, it's pretty cool. I can hit X, or X, and then I can say Shift V and move things up and down. The other thing is, often you'll want to insert a cell somewhere. I can use a browser, I swear. And so I insert cell above and below. So sometimes I want something here instead of down at the bottom, so that's a good tool to have. But if I hit escape and I hit A, it'll go above, and I hit B, it'll go below. So if you're in that command mode, like the whole VI, love command mode. So those are a few things to like help you out today. Okay, maybe I'll take any. Does anybody have any questions? Well, Christine, did you want to? You could run here if you want, but you're going to switch over. Cool. All right, anybody need USB sticks? Anybody have any questions about Jupyter or the tools? Need a stick? Did you need a stick over there? Okay, maybe I can come over. Here's this one. Do you want the USB stick? Oh, you can't. Unfortunately, that means I can't download them either. But there's a lot of them. So if that's the case, you can go to that binder. So I mean, I literally like. I mean, when you work, there's it's like Mac, Windows, 64, 32-bit. You know, all those pieces. We didn't install all those. So you have to go pick which one you want. So that's why we didn't do that. But so yeah, no, we don't have the installers. So
Okay.
maybe you can cut me in.
Okay, so everyone can move to the number 1 notebook called Pandas. And so the learning objectives, so I don't know if you've seen, but there's plenty of PyData tutorials that have like 3-hour-long, intro to Pandas, 3-hour-long intermediate Pandas. So there's a lot of content to learn in the Pandas API. For today, the objectives were like getting started, and so learning how to read and write data in different formats, understanding how the different data types, what different data types exist in Pandas, how to work, basic work with text data, time series, and then what we call indexing, which is selecting rows of your data frame, how to do group bys, and then some basic plotting that's already available within Pandas, and then we'll move forward to like more advanced plotting with bokeh in the next section. So first, throughout this notebook, we're going to work with what's called Amazon Product Reviews dataset. And we have the link to where you can find all different categories with different sizes, and you can like kind of select which category you like the best. In our case, we're working with one. You can also see what are the different fields that exist in that dataset. We have a reviewer ID, a product ID, the name of the reviewer, whether that review was helpful or not, the text of the review, the overall rating, a summary, and then like the time where that review took place. So just like first step is importing the library we're going to use. It's very standard to say import pandas as PD to keep kind of the namespace of that library. And then we're going to be using, or in this case I'm running 0.18.1. And then there's just like some display options to make it look a little bit nicer in the Jupyter Notebook. But you can also use the default. It's just like so I don't get a lot of rows and a lot of columns, and it's hard for you to like see what I'm doing. So the first one here is looking a little bit what this data set looks like. And we have this JSON GZ. In this case, I'm looking at the reviews from the clothing, shoes, and jewelry category in Amazon. And we can get ahead and get a sense of like, how is the what the data looks inside of it. And we see that actually more than a JSON file is a JSON lines file. So every line is a JSON, but altogether there's not a valid JSON format. And that is going to bring some troubles, and like reading it with the default read JSON API in Pandas. So we need to do a little bit of pre-processing there and gzip it and read the lines there. We can see the length of how many reviews we've got, over almost 300,000 reviews in this category. And now we can actually use the Pandas data frame to load this data set into it. So as you can see, even if you get, life out there is very messy, and so the standard of like read CSV, read JSON, a lot of the times it's, they're not just going to work out of the box just because like how people store and save data out there, which might not follow the right standards. In CSV, everyone separates columns the way they like. Sometimes it can be a tab, sometimes it can be like, the character that the person who saved the CSV wanted to. So you're going to have to play a lot with, separators, formats, etc., to make sure that you can read it appropriately. But once you read it, you get this like nice data frame structure. And you can see it also renders nicely on the Jupyter. So you see this table of the different columns that you've got, the overall text view, a bunch of other columns here, ID, name of the reviewer, summary, and review time. So, there's different options. If you don't like this category of data, you can go and download a different one in the URL and change the path here and start using that category instead of this one in case you don't find this one interesting or you want to explore another one. So once you have this, we're going to keep, in my example, we're going to keep with the same one. So the first exercise we're going to see is I want you to explore the different read and write. So we have this messy JSON. But now from there, from that data frame, you can save it to like CSV, to their default JSON, to different ones. So I just want you to like take a second to for example, click the URL of the pandas. And here you can get all the different formats you can save that data frame to right now. And then try loading it again using the reader, and then looking at the different, the different arguments that you can pass on, like, what's the separation in a CSV file? Do you want to use a tab? Do you want to use spaces? And see if that works for you and when you encounter problems. So kind of like the first, you have your code here. The first thing I want you to do is data frame, and then like do two, and then whatever format you choose that you want to save that one. So I just want to start seeing people like type and see that they're not not asleep. So I need to hear like some like noise, even if it, yeah. Good.
If anybody's lost, please raise your hand and I can try to help people out as much as possible.
Also make sure that like the cells run like like from the beginning. Okay. Yeah. Go ahead.
Oh, that's what is your earring.
Okay. Yeah. So how are people doing? Are people, there were some people that have Windows that might have a problem with some of like the content of the notebook, especially this cell here. They should just like remove it. That's like a Unix command, so it's not going to work. And then I think they also had a problem here. Just removing the RT worked. Yeah. Okay. Okay. Oof, yeah. Anyone else having trouble with running the cells or? Okay. Yeah? Okay. Okay. So, so if we press tab, for example, now we want to see, what we can write this data frame to, and we have clipboard, CSV, Excel, HTML, JSON, whatever. Let's try CSV. And also a nice thing we can do is like add the question mark, and then in the question mark we're going to find here, what arguments we can pass, like pass, right? How we want to name the file, what separation character we want. What delimiter. Default is going to be comma, but since we're working with text data, that might bring some trouble in the separation, right, of like the content. And so you can like get, whether you have columns, whether there's like a header, etc. So if we just do, imagine we just use the default. Let's see if that would work or not. Let's see if that did anything. I just killed my notebook. Let's just gonna call this like test CSV. Oh, sorry. Yeah.
We got a copy of the Macintosh 3.5 Anaconda on that.
Okay. Thanks. Anyone still like not having Anaconda in their that wants a Mac? Yeah.
Did someone put Anaconda on that?
Yeah.
Oh, I could use that.
Okay.
It's like 3-hour download.
Yeah, yeah. You did download Miniconda instead of Anaconda. Miniconda, we were downloading Mini.
No, I never downloaded that full-blown 3.5 version.
Okay, okay, good. So I'll pass it around. Just raise your hand and so we save that, and now we see we have this test CSV over here. And now to read it back in, we're gonna need to use the CSV reader. So let's try and see test data frame read. We have here the read CSV test CSV. Pandas PD. And now let's see how that did. So we see that it wrote another index again, so that's bad. It did seem to like recognize the different columns well. And so how do we get to remove this first, duplication of index and first column? So if we go read CSV here and we add question mark, we can see all the different arguments. All these are different arguments that you can pass to read CSV to make sure that the CSV is read properly. And the one we're looking for is the index column. In our case, we want it says that there's no index column name, but it did save one. So we want to make sure that it reads the first one as the index column. So we need to pass an integer that shows like what column has the index. So if we do index column, and we say the first one, now we get remove of that duplication and we have the right index. So there's a lot of different parameters that we can tune. We're not going to go through all, but this is kind of the process. You like find something that was not read properly. You look at the list of all the arguments you can pass, and you find the one that solves that problem for you. Okay. So as you can see, there's a lot of different files you can read to and from. And then so you can just like play around with it, and any format that you're familiar with that you want to test. But let's move on understanding the different data formats that Pandas has. So the first thing that you do like to get that information is just dataframe.info, and that's going to tell you like how many entries you have, the different column names, and then you're going to see what type they have. You can see we have things like float, 64, int, and then a bunch of things that we call objects. That is just going to be things like strings. And so here it summarizes all the different data types that are found in this data frame, and then an approximation of the memory usage that that data frame has on your computer. So one of the first things that you do when you get a data frame is making sure that you're using the right data types, right? So for example, something that we find is we have this Unix review time, and it's understanding it as an integer, but we really wanted to understand it as a date time. So then we can like do datetime operations with it. So to do that, Pandas has this to-datetime converter. So we just pass it the column that we want to convert and the units. And when we run this, and then we run the info again, we see that the datetime, the Unix review time has changed, and now it's actually using the right data type that we want. Okay, so dataframe.info is kind of like the first steps to make sure that things line up correctly for you. So let's move with, we see that we have several objects, and those objects can be like strings, and we want to know how to work better with text data and what tools that Pandas provides us to work with text data. And something that's pretty nice, it's what's called a string accessor. And we can see, for example, here that we can access a column of Pandas either by using what we saw here, this version of the, using the string, or we can do dot and then the column name if it's just like one word. When we do that, we see we get that column, so we can see like, what's the summary. And then this string accessor, if you do dot string, it's gonna allow you to like have different methods that now you can access. For example, one is going to be, give me the length of that string. And this is very powerful because when we're going to move to doing things in modeling, there's a section of it that's called feature engineering, that's creating new variables that you think might be representative of whatever you want to predict or model. So maybe the letters, like maybe the length of the string of the summary is an indicator to predict something. So you need to create this additional column with that information. And by having these accessors to those variables being so easily to get, it's pretty nice. So the next exercise is going, you can go to like the pandas docs, and you can see all the different methods that are available with this string accessor, and you can try and play with it and get things like lower or upper, or even things like find a specific pattern. Imagine you want to find all the reviews that have love in their summary. So you can you can find a pattern and then just use the method string contains in that pattern, and that's going to retrieve a Boolean saying whether that row contains that pattern or not. So just like play around with a little bit with this string, these different methods, and like trying to find any pattern on the summary, either in the summary or the full review text that you might be interested in knowing. And if other people were still having troubles having Anaconda installed locally, just raise your hands who had the.
Someone put a Anaconda Mac version on one of these sticks. Okay, that's the stick. There we go.
Anyone else having trouble? Hello? Yeah. So as I was getting some questions on, people trying to like find, for example, the first word, great, using the pattern and not working. And that's because, when we run this data frame summary string lower, it doesn't modify the underlying data frame. So once you do this, the data frame summary is still like the same original one. And if you actually want to replace it, then you have to like, reassign it, for example. So summary is now going to be string and lower. And now if we do check it, we now see that we've actually like modified the data frame. So like someone was asking me if I, concatenating the lower and then defining, for example, great, that's when now you could like do string and something like, contains great. Yeah. Okay.
You don't have to modify the summary. It looks like if you just the df summary str dot lower, then just cast it back to dot str, and
Okay.
you can do the contains in a word.
Okay, that's another option. Like what I wanted to like demonstrate here is that the data frames are immutable unless like you like modify them. Yeah, but yeah, we can do that too here. So if we read the data frame again, let's do that. So I read the data frame again, and now instead of, so now if I go back to data frame summary, I still get the one with a capital great. And now, as you were saying, we can do data frames summary, and now string, lower, and now string again, and then contains great. And we can still get it. But the kind of like the important thing is that here the underlying data frame summary has not changed. So it pretty much depends on what do you know, but that you understand like what to expect when you do one option or the other one. Okay. Yeah.
So it's just outputting a copy of that data
Yeah.
type overriding it.
Exactly. And you can save that copy into like another data frame if you want to like say.
So that's the standard behavior with
Yeah.
Python.
Yeah.
Yeah, so I was just trying to mix up declaring true and false and boolean values, and I got this error that says something about NA values not index on any values. Does that row always return booleans, or does it ever return like a null?
In this, it should always return like either true or false. It should be able to find that pattern or not find it, but create an NA from there would be weird. So if you can see why you. Okay, so let's move to working with time series data. And so similarly, like what we have with the string accessor, we can also access the date time. So in our case, we have this Unix review time. And now the cool thing is like with the datetime accessor, we can access a lot of date-related values that Pandas has already built in for us. So things like what was the date of the day of the week? What was the week of the year? Things like what quarter was that date in? And that automatically allows us to create new columns that might be relevant for our analysis without having to, build our own and checking whether, if that day was a Wednesday or a Thursday. If we think that, whether it was a Wednesday or Thursday is relevant for our analysis, we can directly use this accessor. So again, we have in Pandas, I don't know if I have the link here, but you can also, another thing you can do is when you do tab, let me see. Oh, I didn't, oh. Run all. Yeah, that's someone else was asking me, like, you need to run everything in sequence. If you skip cells, you're not going to, get the same afterwards, or you get errors. So here. So here we have the datetime, and so you can see everything you can access. You can access the date, the day of the week, day of the year, how many days were in that month, and so I just want you like to explore with this datetime accessor and see like what things you can get out of it. And you can also, in like the Pandas docs, if you're also like going back and forth, there's also a section of working with, I think it's this one, date functionality, and I think if there's a list. Here's a list of different things that you're able to access from like datetime, if you want to go back and forth and like make sure that you get those. And if anyone has more questions, just raise your hand. Okay. like higher numbers at the beginning than at the end. And that's why probably because when you started the notebook, all the cells were already run previously. And so, or as you were rerunning, there's maybe like a 5 that was run in the bottom, and then you're rerunning again at the top. And so that tells you like the order that they were run. But if you load it from start, it might have like the right, like whoever run it last, those numbers saved.
Some idea of how they, what sequence they were, have been running.
Yeah.
Okay, all right, thanks. And I've been doing various rerun yeah, that's kind of makes sense. Okay, and rerun those. Yeah, okay, cool. I just never noticed the first one.
So we're gonna take a break now. I think there's Andy. How long is the break? 10 minutes, and there's food and drinks outside. Yeah. Um, so if you wanna, take the 10-minute break. The first part was a little like slower because we were making sure everyone had the environments set up and was running. But like the next sections should be a little bit more fluid now that everyone has everything running.
he's talking. Yeah. Let me wake it up. Awesome. I think we're about done with our break. Although we might have read the email wrong because nobody else took a break at this time. People send me emails like I read them. I'm like, that's what delete's for. Come on, guys. If you have the, anybody have the USB sticks? Either let me know, throw them at me, so we can go infect other computers. I mean, help other people. Anybody do a virus scan on them? Anybody? Nobody? No one? Awesome. Any other USB sticks? All right.
Okay.
Yeah, I'm collecting USB sticks, so I have them. Oh, you guys are the horde. You want 2 viruses instead of 1. Awesome.
All virus stuff.
Awesome.
Okay, let's keep going. So what we have left is indexing, grouping by, and plotting. And so what we call indexing in pandas, if you're familiar with SQL, is just like selecting some rows from your data frame. And there are different types of indexing. We're going to see Boolean indexing, which is like giving a clause, right, that it can be either false or true. You can select the items that fulfill that Boolean clause. So for example, here we want to see which rows had an overall rating that's like less than 5, which means like that it's not 5 because numbers go from 1 to 5. And then just like to select those rows, we're just going to say data frame and then pass the clause like this. And now we can get the rows that actually like satisfy this requirement. And then like you can like, put in here whatever thing you want. Like, if you're familiar with SQL, like in the where you would usually put the where clause, that's what we can do here. But you can also use this lock location where we don't just like pass this where function, but then like also select what columns we want to retrieve. So instead of like retrieving the full data frame, we just want to select the review, overall review, and the text per se. We can do that as well like this. We can also combine different clauses, right, with the and. And so we want to have the overall equals 5, and then and also have the string that contains the word awesome. Or this is the combination for or that it has the overall review of 1 and contains the word terrible. And we can see from all of our reviews, there's 3,000 that have a 5 and contain the word awesome, or have an overall review of 1 and contain the word terrible. And here, like, there's, for example, one exercise that you can like try and write. So we want to select the rows that have an overall rating of 5, were rated on a Monday, and contain the word love in the review, for example. So try doing that. Yep, questions? Any other questions? I see people not typing. Is it just already solved? You can like query whatever. You can try and like come up with your own what I would like to like retrieve based on like what we've learned so far, based on like the datetime functions like strings or other columns that exist in the data frame. And if you have some problems running, still someone that I bet there's still someone who doesn't have installed Anaconda locally or is not able to run the notebook. Yeah? So, yeah. More trouble like getting things running? Yep. Okay, did everyone get this number of rows? And no? So just like I was also checking this to make sure that, so the day of the week according to Pandas starts on a Monday, instead of some people think that weeks start on a Sunday. This is like the default, like the. So the query would be, I want to know that the overall is a 5, that the day of the week was a Monday, and that the review contains the word love. If anyone had wasn't able to get this and has questions, please raise your hand. Okay, no questions. Let's keep moving. So another thing that's very interesting is getting the different value counts. So for example, we want to know how many reviews did each product get. So we can check the value counts of the products, and we can see what are the top 3 reviews. And then with this indexing, we can select, say, okay, I want to retrieve the reviews of the top 3 products, most reviewed products. So now I can use this is in, and this is in this top 3 products. And so that's how I can retrieve things more complicated, right? So again, I count how many reviews each product had. I get the top 3, and then I pass these top 3 into this is in this kind of list of products that I want. And so this way I get the reviews from the top 3 most rated products. Another exercise that you can do, and I think I have the solution here, is do the same for get the reviews from the top 3 most reviewed days. And what date? And a funny thing here was that the most reviewed days was the day after Christmas and New Year's Eve. That's when of 2013. Something happened there that a lot of people started reviewing. Unhappy people with their Christmas presents. So this is very similar. Again, this is an exercise you can try on your own, or we can move on to the next part, that's grouping. And so this is if people are familiar with SQL, very similar, the group by functionality. In this case, we have this group by. We pass in what type of grouper do we want, and then we can compute any aggregation function that we want on those different groups. So for example, here, if we wanted, by product, the same way we did before on value counts, but we want to use this group by functionality, we can group by product and then count and sort those values. Then I have several exercises here that you can try out. So compute the average rating per product, the average rating per user, the average number of ratings per day of the week, and the standard deviation rating per product. Yeah. Should I Okay, in order to be able to go through all the materials that we have, we still have 2 libraries that we want to visit, Bokeh and scikit-learn. I'll leave this exercises to review at the end if anyone has troubles getting the solutions. And then we'll skip the plotting part because we're going to go more in depth with the interactive visualizations in Bokeh. And then just so to review what we've learned today, reading and writing data using these parts of the pandas API, understanding how to format the pandas data types, working with the string accessor, the datetime accessor, and basic indexing and grouping. So now I'll pass it to Andy to. Do you need power?
Yeah, that sounds great. Everybody having fun? Awesome. Let's get here. So, looks like there's some questions happening on the Google Doc. Really happy that it's happening. You never know if people are going to play along. So, we're going to switch over to Bokeh. And so if you come execute this guy. So now we get to pretty pictures. Yay. That's my favorite part. All right, so we have a lot of data. We've just looked at basically rows in a visual context. And actually, there's this really cool feature of pandas now. It's called, you can add a style attribute to these things. And you can do really wicked cool things like paint colors and make things flash and have pandas walk across your screen. I mean, no, maybe not that. But so definitely a lot more to check out there. And I can send out some tutorials by Tom Osberger that's modern pandas. It's so old they have a modern version now. But we're going to switch over to Bokeh. And so Bokeh is focused on the visual aspect. So anytime you start getting with data, at some point, you really need to start looking at something. And the visual media is just so powerful for when you're expressing what's going on. So you can usually get a good idea of what's happening, but it's hard to look at 1,000 data points in that little data frame, right? And so then that's when you need to turn to something that's a little bit more visual that gives you an idea of what's going on. So to start, I think there's a few things we forgot to mention, but I think everyone's figured it out. So to execute these things, you have to hit Shift-Enter on every single cell. Otherwise, it won't load it because you just have an interpreter on the back end. So it's going to load it. So I hit Shift-Enter. You can even hit Shift-Enter on the markdown. It's not going to hurt anything. So I hit Shift-Enter here, and what this does is it loads the Bokeh JavaScript library. So Bokeh is a Python tool. It's all Python interface, but what it'll do is it'll generate JavaScript, and so that you can interact with it on the browser. And if you are a JavaScript wizard, you can go actually use Bokeh.js as its own independent library into the JavaScript world. So let's just get started with a very simple notion. What I have here is NumPy array. So we haven't really introduced NumPy, but you used pandas, and pandas uses NumPy, so you all know NumPy now. Awesome. Transitive knowledge. So what I do here is I say, you don't have to worry about too much. So if I say escape B, showing off the cookies. I just say len r, it actually just gives me an array of numbers. And I then say, give me the sine function over that array of numbers and the cosine function over the array of numbers. So all I have here are 3 arrays and evaluated at different points. And so our first plot, yay, I say, give me a figure, which came from Bokeh plotting that I snuck in an import statement up here. I didn't explain it, but I thought I did. Oh, it snuck in here. So often you'll have this Bokeh plotting import star, and there's a lot of features. So if there's something that doesn't make sense, ask. So I create a figure, say, hey, give me a scatter plot, and I give you my x's and my y's and a color. So I have a sine and a cosine, and I give it color. And notice I can give web colors. I can give named colors. I can give it RGB values. There's a lot of things you can do with colors, and we'll look at a little bit of those later. And immediately I get a plot out. Everybody saw that from the data, right? Everyone saw this. So you can see here this green thing going up and down, and this purple thing going up and down. And everyone's like, yay, trig, awesome. One of the neat features is right away, Bouquet gives you some features that are free. For example, you get this resize thing, so you can resize this guy. So you can make it all funky looking. So maybe I want, like on small screens, I put it there. And then I have a box zoom, so maybe I want to look at just a single region, like that. Bam, can do that. There's wheel zoom. If I kick that, I'm actually zooming on the wheel version. Whee! You hit the save button, it'll give you a graphic from the web graphic and whatnot, and I hit reset, and I'm back to what I started with. Okay. Oh, and then there's pan, which sometimes you want to use. Cool. So that's our first interactivity, is just interacting with the plot itself. Plot some data. You can zoom in where you need to, and so on. And so these arrays here, you can think of these as just the columns in a pandas data frame. So the actual column is actually a NumPy array with an extended version of NumPy array. So you can just plug those things in here. That's why we kind of started with that. Everybody able to execute this guy? Anybody not able to execute this? Okay. I think your work is cut out for you, Christine.
Just missing graphs here. Like I missed.
This one here?
So
Yeah. So this guy right here, lin array creates what's called a linear space from 0 to 4 pi. Okay, so just like range iterates from 0 to some number, this thing does it. It says, give me a range from 0 to 4 pi with n points. So I have here I could just put 3, for example, and then I'd only have 3 points, right? And so, and this np.sign, right? So the sign array is just takes that the sign function, applies it at 0, at 6.2, at 12.5, and so that way we get, and you can see the same thing with the cosine array. So this is actually when you actually call the dot stir or dot mean in your Pandas series, it's actually called a NumPy arrays underneath the hood, and so it's the same sort of idea there, and we just wanted a big one so we'd have a nice dense plot. Okay, any other questions? Everyone got a plot, except those who raise their hands, and Christine's coming around. Cool. So the next bit is I have an exercise of just play with colors, markers, alphas, and size of input. So come here, make your red guy. So we have red. So marker is another feature, another attribute in here. So in this I say square, marker.square. I have this funky square. Turns out if you're really awesome and you want to really deep dive, you can make your own markers. There's a whole glyph library. I've seen people plot with Homer heads.
are you using binder?
So-
We're not able to get them
and we make that
running
green.
locally?
So yeah, so take a minute, make some different plots, make different colors, add different pieces there. You can see all the glyph types here. Like there's an annulus.
Binder
And you
protection,
can see some
so
funky
it doesn't load the
annuluses.
JavaScript in case,
There's a lot of them actually. There's a star thing.
like someone tries to hack
Yeah,
their
Bezier curves.
infrastructure, so it might be a protection of.
This one's a
moving
circle. So start playing around. Instead of dot scatter, use dot annulus and plot. Use dot circle or circle cross. I'll give you guys about 3 minutes to do that. Okay, anybody have a favorite marker? Who's a favorite? Want to shout out their favorite? No one? No one? Nothing? Okay. Anybody who actually did the exercise? So I know who I'm working with. Awesome. How many people are checking email? No one. Awesome. We're doing good things here, Christine. This is awesome. All right, so hopefully you've got a little bit now you can change the different attributes. And the reason you do this is that when you're applying a data set, we'll get to it, like often you want one feature in a different color or a different shape or things like that. And so this is something you often do in your data viz. So the next lesson is that everything is vectorized. So where you had, like, for example, up here, you could have changed size. And like, let me just do one, right? So I can say size equals 10 billion. And I get like, oh my God, you know? So maybe calm it down and you can get a bigger size, right? And you can change size. But what happens if I want a size based on the data? Well, I can do the same thing I did with NumPy or with this pandas and give it that array or the pandas column. I square it with that pound square and multiply it by 10. So I square it. Anybody know why? Anybody? Yes, so I can make sure it's positive. Because if you give it a negative size, HTML doesn't really know what to do with that. So we square it and make it positive. I multiply by 10 so you can see it. And then I get this thing, and we see the size change as the data changes. Okay? So that right there was enough to sell me I'm okay. Because now you can take any piece of data set and make your plot respond to your data. And it works for pretty much everything. Here's an example here. We're going to change the color based upon the data. So if I look at bouquet.palettes, so I get my color palettes, I pull out the excellent color palette Brewer, and I say, and it gives me, if you look at this thing, I have some, it gives me a dictionary, so you have to like work with it a little bit. So it gives me a dictionary, I have greens or oranges, BU, PU, I don't know what PU is, but hopefully it doesn't smell too bad. So I say, you know what, I'm colorblind, so let's just do gray. So I pull out the grays. Now what I do here is a little funky. I say, all right, I'm going to give it a palette, but I want the grays. I want the grays that has 9 different grays in it, because the way this thing works is it gives you grays, and it gives you like 5 or 6 or 7 grays. So it gives you different, like how many colors you really want. And then I reverse the list and go to back again. That way I go from, you know, like 0 to 10, and then I don't go to 0 again, so I don't have that shock wave of like, I got to 10 and I went back to 11 was 0. So I go back and say, all right, now I want 11 to be actually 9, and then it's back, and so on and so forth. So that makes a nice pattern for me. Then I make colors, and I build this colors. This is, so what I'm doing, this is a list. I multiply it by the length of that list, divided by the palette. So you take how many of these sets of colors do I have, and make my palette that long. So if you multiply a list by a number in Python, it just adds it up, concatenates it. So I say 10. I want 10 of these things. It gives me 10 of them, and that comes from our data we picked out. And this is just the module. So give me the rest of the palette, right? So all that's a lot of little details to get a set of colors, which is just an array of these colors. Now I pass in fill colors. And you can see, not only am I varying by size, but my color as well. And it's a different pattern going on there. What is going on with it? Is that, oh, it's the food back there. Awesome. So now we can do even fill, you can do alphas, you can do all sorts of pieces there. So let me give you a minute to kind of like grok that and make a new plot, play around with, like alpha is a good one to play with some aspect of the data. There's also fill alpha. Let's see here. There's some other good properties. Doobie-doobie-doo. Okay. So I can't really. So if ever bouquet.pydata.org is down, you should email me, because I'm apparently the guy who does that. But so yeah, so here's tools. There's a whole list of them. Oh, they've changed this. Okay, so that's actually the wrong place. I was going to go to parameters and okay. All right, so everybody have a vectorized plot of their data? Anybody questions? Nope. Okay, cool. I'm gonna go ahead and go on. I've got to be respectful of time because I think they do have lunch for us at noon. All right, so the next bit is like the tools. So those tools that I had at the top, that like pan, zoom, and whatnot, you actually can create your own custom tools because sometimes it's not really enough just to like have the data in some different color in different places. It gives you a lot of insight, but you want like something a little bit more to it. So in order to do this, we have to do a little bit of setup. What we do here first is we create a data source. And there's a lot, you're going to see me create data sources in different ways. Like the first way here is just to call it and call the data with a dict and a dictionary of names and arrays, okay? And so what this guy is going to do is it sets up an object that if anything changes on it, it's going to notify things that are listening to it, okay? So it's got this kind of back and forth. It's traits. So if you ever played with the old ETS traits library and things like that, so it's got these listeners and whatnot on it. So I have my column data source, and now I'm going to create different tools. And there's a lot of different ways to create these tools. Like the first way is just to do a string with the names of them. And it's a nice creature function. You can just pass tools of this function there, and you say, I have a crosshair, a pan, a zoom, a box zoom, a reset, and you can put whatever tools you want. And so in this case, I do a circle here. I play with fill color, fill alpha, which is just a number. Notice here, instead of the source being like giving the arrays, I give the source, and then I give the name of the attribute on the source. Okay, so that way it knows, go watch that source, and then I will look at that piece there. And sometimes if you misspell these things, you'll get a plot that has nothing in it, so go check your sources. That's usually the first thing to do. Now this bit here is I want to have a hover tool. And because we did it this way, we have to say, all right, plot 6, give me the thing that's of type hover tool. And so it'll select off the hover tool and give you the hover tool, and that's what hover is. And in hover, I give it an ordered dictionary because I want it to be ordered. And I say my index is, and notice here I have, there's kind of a little sub-language here. So I do the $ index, and that says give me the index of the data set, and then I have at, and like at that index, give me the x value and the y value, and then I have at, give me the size, and then there's this thing here, just copy and paste it. I don't even know. I've asked Brian many times, like why do I need this? But if you don't do that, the fill color of the hover tips don't look great. So I hit Shift Enter. Oh, it worked, and bam, I have hovers. So now, when I'm like, why has that thing disappeared? I can come here and look. Oh, well, okay, I can't do that because I didn't put the alpha in there. But I could put the alpha in there and see what it is. But you can see kind of the size 14, that sort of thing. So this gives immediately a way to interact with the data and see exactly what's going on. And so that's the hover plot. Go change something and have some fun. See, fill alpha. So is that what I have in here? Yeah. So let's say, does that work? And now I have fill alpha. Question. Yeah, it doesn't. Yeah, that didn't work. Why didn't it work? Because it's not on my data source. That's why it didn't work. So why don't I do this? Fill alpha equals fill alpha. Oh, no. Let's just do here. Yeah, thank you. Comma after colors. Let's put this here. I don't think this will work, but I'll try it. Maybe it will. No, it didn't work. Float is not iterable. So what we really need here is something like this, right? So what happened is I just put the so I said you just put a number there, and it wants an array, or something like an array. So for I in len r, this is totally terrible code, but whatever. No, it still didn't work. Float is not iterable. Maybe it is not. So this is the part where you're like, oh, okay, so maybe I should just stop and like figure it out later. What is, did execute that? Executed that. I've been telling everyone how to do this. Yep, did run it. Now something's going wrong, and I'm not quite sure. Is it the last comma? Yeah, back in your. Right here? Yeah. I hope not. Yeah, that would be really terrible. Ah. Keep shouting them out. I'm going to give this 2 more seconds. Let's try this. Nope. All right, so that totally failed. To an integer. I don't know if that would work. Okay. So I'll have to figure that out, and I'll come back to you guys. Oh, there it is. That underscore. Right? No, that's not it. That totally isn't it. Okay, well, so we'll figure that out in a minute, and I'll come back to you guys. So totally awesome. Sometimes you have to like work with it a bit. Let's just change this back to 0.6. It's the hover tip that's giving me problems. Oh, everything's giving me problems now. Oh no, oh no, demo fail. Hey, awesome, linking 2 plots. All right. The next kind of really cool feature is that you can link 2 plots together through that data source. And so here, I do the same sort of thing setup-wise. I have n equals 300, create same arrays. Then I add, so here I create my data source, and then I add things to it iteratively. So I can just use this add, and it's the same thing as that dict, except I can kind of add pieces to it over the time. So if I have some sort of an app that's running, and I have a data source, I can actually add pieces to it, and so that you can execute it later. And so I guess I should mention, like, all these things work on an embedded web app. They work on their own web server. I mean, there's lots of ways to deploy these. We're just using the notebook because it's easy and fast to get going. But there's definitely people who deploy these on like their web scale. Well, I don't know about web scale, but their apps and whatnot. So we pull off some tools. We have the scatter. We do this thing called grid. So okay, so there's a little subtlety here. Let me stop a little bit. So I have sources here, and then I create this new figure, and I should have, everything's broken now. I have to really figure out what it is. Yeah, but I'm not sure where I broke things. All right, I can't quite hear you, so. Yeah. No, I totally screwed something up. All right, we're going to do the old-fashioned way. All right, shut everything down. Start up again. Let's see if this works. Sometimes that works. Leave this page. Yeah, come on. Uh-oh. Can I borrow your computer, Christine? What did I do? It's the first time it's ever happened, I swear. clear all output. Run all. So here's another neat trick that as you're using these things, you can hit run all and it'll run everything for you. And so if someone hands you a notebook, then you know it usually works. So when you get down here, everything is vectorized. Awesome. Working, working, working. Yay. It works. Ah, thank God. That was actually planned to show you that nothing ever works, right? Okay, so what's happening here? So I have this figure, right? I have scatter on it. And then I have this thing here, this X range bit. And so X range is just the range of the X axis. And instead of you can actually give it a list or whatnot. So this is something you can do if you want to change the names of something, right? And so it'll for example, if I want a much bigger or just a smaller than what my data is, you can change this guy. But if I set it to the property off of the S1, now those guys are linked. And that column data source, which is listening to things that change, will change back and forth. Okay, so this is what the power of using these listeners and whatnot. And so now I use grid plot to plot two things together. Now any change I make to one happens to the other one. So you can make, but look, it doesn't happen on the Y. You want to know why it doesn't happen on the Y? Yeah, I didn't make it happen on the Y. Should I try to make it happen on the Y, or should I just say demos are awesome? Do it. All right, let's hear. Bam. Oh, it worked. The other cool part is that often what you'll do is I have some piece of data I want to understand between two graphs, and it will select both sides. So this is something that, go try to do that in an afternoon. So I grab some stuff, switch. So that was the lasso tool there. Now I just want to go pan and say, all right, pan over here. There we go. Maybe we'll zoom it in. Yeah. So we can play around with that in a little bit. All right, so that's getting down to select data interactively. So the next bit is probably, someone asked me earlier, how do I deal with the fact that I have tons of data and I only want to see different bits of it, right? And so there's this notion of interactivity. And we're going to show you one way of interacting with the data source interactively via the notebook. After this, if you want to actually make this work on a web server, go look at the tutorials. There's lots of examples on the Bouquet gallery and whatnot. But for today, we're just going to use the notebook's interactivity. So I do the same thing I did before. I create a linear space, multiply it by sign, make my data source, and I do it the first way that broke on me when I tried to touch it. So, and then I make my title. Notice I can actually add more things to my figure, so I can height, width, those sorts of things. Make a line with my source, and even give it a name. And I don't plot it right away. I just create the plot. So the next thing I do is I create this interactive widget. So from IPython, and so there's a few things here that's old because I learned to use these things before the last update. So you should be using bouquet.io.pushNotebook as opposed to this. So I have this @interact function, which came from IPython. So IPython has these widgets that'll create this thing below here. And what it's doing here is I say I have an f to a function which takes the input sine, cosine, tangent, and it automatically figures out that list is a selector. Then I have w from 0 to 100. Oh, that must be ints, and I can play with ints. I have a and phi. Phi, you notice I have 0 to 10, but I have my step function is 0.1, so hey, that must be a floating point number, and it automatically creates it. Really powerful for just creating something very quickly, right? Now, of course, that's just the 10,000 level foot, And I have some examples that use like different pieces of widgets if you want to customize to exactly what you want, right? It's just great for data scientists, terrible for like exact UI. So, what's that? Not yet. All I was doing is just showing you what creates this widget, okay? So that's this widget here came from this interact and all these pieces there. Now it's a decorator. Does everyone know what a decorator is? Yes? Anybody not know? Okay, nobody's willing to admit it? Okay, so all a decorator is so if I have a function, so I have like def f that takes a func. Right, so a decorator would be, so if I can make that thing into like at f and say def b, and now, don't touch it. And so in here, for example, this at f is the same as saying b equals f of b, effectively. So there's a lot of like fun things you can do with decorators, and I absolutely think you should go touch it, but that's the, okay. And so someone yelled at me, import bokeh. Awesome. Okay, so now what this interact does is it wraps this function. So there's a non-decorative version, you can just give the update function. But I have update, and so I give my f, w, a, and so as I move these things, it's going to call this function with those values from the slider. And so I just have an if statement here. If f is sine, then my func is sine, cosine, tangent. And then I say my data source, I'm going to change y on my data source. And I have this nice formula here that just makes a nice wave based on that function. It gives me an amplitude of phase change and a period. And then I say push to the notebook. So I have to have something that says, all right, in this case it's push notebook. In like a web example, you'd have push somewhere else, like push to the server, things like that. So all this does, every time I touch this, it's going to run this function and then change the data on that plot and update that guy. Does it work? All right, so let's see. Cosine, all right, the function works. The period works. The amplitude works, but it's hard to see because your y-axis is just changing there. And our phase changes. What's changing? Yeah, so that's the auto scaling feature, right? And it's confusing here, but you can turn auto scaling off, right? So there's like every visualization widget, there's a lot of like bells and whistles to press. But awesome, we can change a widget completely from like 10 lines of code. So how does this actually manifest itself in like the real world? Is often what I'll do is I'll have some selector on my data sets. And maybe I should take 10 minutes to run through like how I did this with baseball salaries. Yeah, so and show you like an example. Like also, I guess at the end, I have here like a even higher level chart, which I think it's awesome if you just want like like this shows you how to get a histogram really quickly. You could take it and like if something works for you in charts, like it's great and you can go with it. But I find usually in my day-to-day that charts doesn't have enough like little pieces. It's better to like grade your app as you go. So let me take a little bit of time and show you one of the apps we built. And so we originally had this grand goal that everybody would be working on these examples and exercises, but that didn't happen. So it was totally cool. So I have this baseball app here, which I'm going through, and we read the data, and we play with a bunch of data, and you can kind of come back and look at it. And so here's a case of like I have like salaries of baseball teams from a pandas database. Now, the first thing you notice is you can't read that thing. So you can do this trick where you change the orientation, and like you get a nice readable thing here. So in here, like I compute averages, group bys, and whatnot. And you can see here, like here's a case where and this is the curse of the smaller screen. So here I have like my pay average by baseball team overall, and then the pay ratio. And you see, like, they're not really correlated very well at all. In fact, if I come and these guys, if I say what is like these guys here, you can see that they're actually all over the map. So there's really very little correlation between the pay ratio and how much it is. So here's a case where I'm like, all right, let me take all stars, and is there any correlation between all stars and the pay? And so at the end of the day, as you go through this, you see me doing a lot of pieces to pull out all stars, count the all stars from a different table, and so on and so forth. And I get this plot here, which is based, like, how big is it based on the size is based on the all-star count. Now, at the end of but I can add, like, at the end of the day, baseball happens every year, so I won't do it per year basis. So we create the same sort of idea of an update function, and we pull out all stars for that year. And so in this case, I have bouquet.show, and let me see if did I execute it? No. So I have to go through and execute everything. Run all. So it gets down here. There's even some. All right, so now I have my interactor, and I see 2013, and I can play around with it, and I can select the year I want, right? Like 1997 was a good year. New York Yankees still made more money than everybody, but you can see kind of like there's different kind of slopes. Like these guys, because this is sorted by the 2013 data, right? And so you can see that now Baltimore is probably paying a little bit better than Cincinnati, but that wasn't the case in 97. But you can see that the number of all-stars doesn't really correlate too much with pay. It is the case that Yankees has more all-stars almost always, but not, So here's a case of like an interactive plot where you can build and play around with it. Maybe I should resize this thing and it would work a little bit better on the screen. There we go. So now, cool. And you can play the Gapminder videos. So this is what we mean by exploratory data visualization. Now I can look at every year and have some attribute of this function I look at and try to go find some trends, things that are surprising. So like you can here see how LA is like paid really well and dropped off precipitously the next year in 2005. It's like, what happened? Who'd they fire? Oh, but that's that funky trick, because what happened was the X range changed. So there is some, you got to figure out the tools a little bit. So, cool. So that's kind of like what I would consider like a full app of like running this, being able to play around with selecting data frames and so on. When you have time afterwards, it might behoove you to read this piece, because there's a little bit on here, like this is actually calling to a database and shows you how to like connect to a database and just slurp things out, like read a query and pandas and things like that. So this is kind of like after our talk, look at these exercises and play around with them. So with that, any questions about Bouquet before Christine comes and shows you guys scikit-learn? Deer in headlights. Yay. Okay, cool. Come on. Oop, oop, oop. Here you go.
Okay, can you hear me? Yeah. So how many people here are not familiar at all with machine learning? Like zero, like, okay. How many people think they have like some, introductory knowledge of basic concepts? Okay. How many people have used already scikit-learn? Okay, not many. Okay, so kind of the, I kind of like had this intuition that some people were gonna come here with like not really knowing what machine learning and modeling is. So in this section, it's important to understand both things. One, the concepts, and secondly, kind of the scikit-learn API and how to translate those concepts into using the library. So the concept that we're going to review is like, what are models? When people are talking about machine learning and modeling, what is a model, right? Then we're going to see different types of algorithms that are available and when we want to use each one. And that's clustering, classification, and regression. We're going to then go through like these 3 steps of what to do when people say, we're building a model, and it's kind of the 3 steps that we call fit, predict, and then evaluate a model. We're going to, in the evaluation phase, there's a lot of different metrics that you can compute to compare or understand how good or how bad your model is. And so we're going to see 2 kind of like the basic metrics, which is accuracy and confusion matrix. And then a little bit more like advanced of understanding why those metrics might not be representing well how well your model is going to perform out in the wild. And those are going to be understanding what's overfitting, why we're going to split our data in training and testing sets, and then what's cross-validation. And so from the scikit-learn API, we're going to use we're going to learn like the fit, the predict, accuracy score, confusion matrix, the train test split, and then the cross-validation. So the first thing that we ask ourselves is like, what is a model, right? So we have data. We have people that have implemented algorithms in a library such as like scikit-learn, and we pass the data through that algorithm, and we get some mathematical function that is able to tell us something about the data. That is kind of the most general, right? Like, and that function, it's actually like a mathematical function with some coefficients already like set for us. That kind of is like the output of the algorithm. And then, so when we pass either a part of the data that we use here or a new data, and we pass it through that function, we're going to get something in return. What we get in return can be different things. It can be a value, like a quantitative value. That's what we call regression. Or it can be some type of label, like a classification or a clustering. And what's the difference between classification and clustering? We're going to see in the next step. But kind of this is like the basic understanding of, we have data, we pass it through what for us in this class is going to be a black box, an algorithm that someone has implemented that returns that function. And that function we can use to predict, we're going to call it predict, things on our basic data set. So what kind of algorithms do we have? So in machine learning, a lot of people classify it in 2 basic types. One is called unsupervised learning, and another one's called supervised learning. The unsupervised learning is when we don't have a target value that we call, or a label that we want to predict. It's just like, we have a bunch of data, and we want to do some kind of exploration of grouping things that might be similar together. That's the basic thing about clustering. And then another thing that we might want to do in this unsupervised learning is like, might want to find like some underlying structure in the data that might exist, and I want to find out if it's so, right? We're not going to talk a lot about latent variables or like latent structure. So like just focus on clustering. Clustering, I have a bunch of data. I don't have a target, what we're going to call a target variable or a label that I want to predict. And instead, I just want to group things together and see, how similar they are based on some kind of similarity, how close they are in vectors, or another type of pattern that we can compute that's similar, that we can see it's similar to each other. On the contrary, when people talk about supervised learning, we have one variable in our data set that we want to predict in the future, but we currently have an existing data set that we know that value for. Okay, so we have a data set, and that value is what we're going to call the target. So imagine, let's imagine the Amazon reviews. we can think that that target can be whether a review was helpful or not. We have a label, and we have like a value, and we can say it was it can be binary, right? Like it can be yes, it was helpful, no, it was not helpful. And we want to predict, giving a new review that someone writes, can I predict whether that review is going to be helpful for people or not? So that's kind of and that because it's a label, so it's a categorical value, we're going to call that classification. If on the contrary, for example, the Boston housing data set, if what I want to predict is a value of a house, that's a quantitative value. And I already have the value. I know what someone paid for it. So that value exists, right? So that's in my data set. That's my target. But now instead of a label of like, was it helpful or not, now I have a quantitative value. So now if a new house comes to the market, I want to be able to say, what do I predict that house is going to sell for? Yeah? Are these basic concepts clear? Any questions? Okay. So this, and for each of this, we have a bunch of different algorithms that we can use to do those, to do those things like clustering, classification, and regression. And this, for example, for clustering, we have k-means, hierarchical clustering. For classification, we have logistic regression, SVM, decision trees, KNN. For regression, we have things like linear regressions. And those algorithms are the ones that you're going to find in scikit-learn. Okay, so now we have a bunch of algorithms. We have some data. We put them together, and we're going to get a model. So what's this three-step modeling process of like fitting, predicting, and evaluating? So the first part, the fitting, is the one we just said. We have data. We have a toolbox of algorithms. We put them together, and we output a model. In this case, prior to the fitting, we need to have some data. In this case, we're just going to make random data. Scikit-learn has a module called datasets, and from there you can like load existing datasets, or make some like artificial that are good for teaching what those things do. So we have the x and the y. I mentioned earlier, in general, when we're doing clustering, we don't know this y, right? But in this case, because we want to test how good our algorithms are, we do know what was the distribution that each of the different groups came from. But this is not something we're going to know out in the wild. That's why it's an unsupervised model. But we do want it here because we want to be able to test our algorithms. If we didn't have it, there was no way for us to like know how well this clustering algorithm was working. And that's kind of a problem that happens in real life in clustering, is that you never have this y in real life. So you don't know. And you have to come up with different metrics to assess that. So algorithm. So now is where we go. We have the data. It can be something generated from scikit-learn or something that we have on our own. And now we go to our scikit-learn toolbox and get a clustering. In this case, we're doing clustering, and we get a clustering algorithm. In this case, from scikit-learn cluster, we import k-means, which is one of the clustering algorithms. We initiate this algorithm, and we pass some parameters. In this case, I know that I need 3 clusters, but that you can pass whatever parameter that you want. And that's kind of one of the problems, setting those parameters, knowing what should I put there. And that's kind of, at the end, you're going to start tweaking the different variables and see how your model changes in your evaluation metrics to find what are the best parameters to input to your model. And that's how kind of like the circle works on trying to optimize your models. So now that I have my model, I do the first part, that's fitting. That's building this model. That's building this mathematical equation. So this is how it works. It's a very simple API that scikit-learn has. So call my model.fit, and I pass the x, which is my data. Once that I've fitted my model, now I can predict using this same data set that I have, and see like how well this model is performing on the data set that it used to create it. And that is something that we're going to see that's not always what we're going to do, but just like to start, so like we understand the different steps. So now this is using my X to predict how am I going to group these different instances. And for here, I can save this prediction and call it cluster labels. And that, like, I see the prediction is going to tell me, does this instance belong to like group 1, well, 0, 1, or 2? And all the zeros belong to the same cluster, all the ones belong to the same cluster, all the twos belong to the same cluster. And this is how I'm grouping things without knowing, because I've never passed my target anywhere. So the algorithm has never seen what's the real cluster that they belong to. And see, like, from there, like, what is it, where is it assigning, how is it grouping things together? So now I have some predictions, and next I want to see how good did my model perform. And so there's two basic metrics that we use, that's accuracy score and confusion matrix. The accuracy score, now I'm going to pass the real values that I know those data sets belong, how they're clustered together, because I know, because I created these blobs, I know the underlying distribution that generated them. So now I know the reality, and I know what my algorithm predicted. I compare that, and it tells me like a very low accuracy score. And this is just because if we look at the confusion matrix, and that's what's important to like look at the confusion matrix, is that it grouped them together. It just like the algorithm used different 0, 1s, and 2s. And 0, 1, and 2 is just like random. So it grouped things correctly. It just labeled 0 as 1, 1 as 2, and 2 as 0, or whatever combination. And that's just like random. So to adjust for that, in scikit-learn, it's called adjusted score, random score. And when you do that, it tells you that it assigned everything 100%, which it means like it grouped every cluster with the instances together that it belongs. It doesn't matter if I call 0 to cluster A, and my algorithm calls 1 cluster A. It's still like grouping things correctly. Any questions up till here? Yeah? Yeah. So X here is like my data. So the data variables that the algorithm is using to predict what cluster you belong to. So when I go here, X is for the, I'm using the make blobs, which is like generating a data set for me. So I'm going to run.
Just to give some flavor on that, that X would be your data frame. So you have your data frame. Once you tidy up your data frame, X is just all that data, except in scikit-learn, it pulls it out as just an array. But it's a 2D columns, rows. So each row being an example, each column being a feature.
Yeah. And in your, it removes, so if you have a target, in this case, you're not going to have a target because we're using clustering, but if you were doing classification or regression, you would remove the Y, which is the target, what you want to predict from the X. So in the X would be all the variables that you're using to predict the Y in your data frame. Okay? Any other questions? Okay. So, yeah. So now that we've gone through that, let's just like take a look at these two evaluation metrics that we talked to. Like one is accuracy and the other one's confusion matrix. So accuracy is one that can be misleading, and this is like one example. Imagine that were predicting whether a review was positive or negative. But we had 95% of positive reviews and just 5% of negative reviews. If my model assigned to all the reviews the label positive, the accuracy of my model would be 95%, which sounds like a very good number, right? 95%, like, oh, you're doing 95% right. But my model is unable to predict when a review is going to be negative. So I want to be able to like have this. What if like imagine that in this case the impact might be might seem trivial, but imagine the case of trying to predict whether a tumor cell has cancer, is malignant versus benign. In this, my model here would be telling everyone that's healthy. 100, and I would be saying my model is 95% correct, and thinking, oh, it's doing a great job. 95% of the time seems like it's close to 100. Well, if 5%, if I'm telling just everyone that's healthy, I'm not telling anyone that they should go get treatment. So I want to be able to like identify with like a closer look what is my model doing, and that's kind of like the next level down is the confusion matrix. Because if I'm using the confusion matrix, now I'm able to see, oh, wait, I'm predicting 100% of the time I'm predicting the positive correctly, but 100% of the time I'm predicting the negative incorrectly. And now I can see this like, and if this is really like my, the importance of if even this 5% is really why I'm building this model in the first place, imagine like the cancer example, then I'm going to focus on getting this 5% right versus like this 95%. So this is how I get the next detail. So now I want you to do an exercise. So I'm using another data set that scikit-learn comes from. And if you're doing machine learning at any time, you're going to see this data set over and over again, which is called the iris data set. And so I load it, and I'm going to separate. And this is a classification problem instead of a clustering problem. And that's why I'm separating the x and the y. And so what I want you to do is go through the same steps. Pick a classifier. And here I've given you some examples of classifiers that exist. And we're going to treat this as our black box. And you can find more of these black boxes here. And then I just want to fit the model using the API and predict it, and then evaluate using the accuracy and confusion matrix. So like 5 minutes, try and do it. What are the columns? Yeah, so let me open this. So if you do iris, it gives you a description of everything that there is, and if you just do iris.data, you just get the arrays. But you can find the columns here. It describes everything. So you get the sepal length, sepal width, petal length, and petal width of the flowers, and you have to predict what type of iris flower it is. And there's 3 different types of iris flowers. If anyone has questions, you can raise your hand, or having trouble running the notebook. Yep. Okay, did you get the? So the idea was just to reproduce like the same process. So you can pick a classifier, either one of them, just like uncomment, or find one that's in this example. You start the model, you fit it. In this case, because we are doing classification versus clustering, we now can use the target to fit our model, because like that's something that is going to be in your data set, your real data set. We can predict, and now we can compute the accuracy score and the confusion matrix using the real y, which is the one that we had originally in our data set, and the y predict, which is like the output of what my model thinks. Yeah? Yeah. Any questions? What? The Boston, you want to, what? So you want me to skip the, oh, what time is it? Okay, so everything's clear till now. So what's the problem with the process we followed up till now? So the problem is the following. So we have a training data that we're using to predict things that we wish we could extrapolate to things that we have not seen yet, right? So Amazon reviews. You want to be able to predict whether a review was helpful from the next review that someone's going to do, not from something that we've already seen, right? So right now, we're just using our same training data to do the fitting, the prediction, and the evaluation. And that's kind of like lying to ourselves, because the model is using all that information to make the prediction. But for the unseen future review that someone writes, the model's not going to be able to see that. So somehow we need to replicate what's going to happen in reality. And what's going to happen in reality is there's part of the data that my model's never going to see. And I want to know how well my model is going to perform in data that's unseen. And that's why we usually separate what is called training data and testing data, and never use the testing data to fit the model, just using to evaluate how good my model is. Because then it's going to be more accurate to what's going to happen in reality for things that I've not seen, how good my model is going to perform, versus just counting on things that I've already seen, which is always going to be better, or most of the time it's going to be better, because all the data was used to build that model. And I might be finding things that are just specifically for that data set, but they're not well generalized to the unseen full scope of the data that's going to come in the future. So that's something that happens usually. I just training with my data, I model it and evaluate it, and I think I'm doing a great job. But then new data comes, and I use the same model, and now my results are terrible. And so to solve that problem, I'm going to split the data in two, one part to use it for training the model, and another one for evaluating it. And in scikit-learn, that's inside the module called cross-validation, and it's called train-test-split. And so when I use train-test-split, I still pass my x and my y, and now I give it a test size, which means 40% of my data set is going to be used to testing, and 60% to training. And now the output of this is this 4 components. The x, so the variables that I'm using to build the model. So the x test, which I'm not going to use to build the model, I'm just going to use to evaluate it. The target variable y train, and the target variable y test. Now we can do it again, for example, using another classifier, in this case, nearest neighbors. Again, we do the same, but now when I pass fit, I pass just the training set, nothing for the testing set. So my model never sees that part. And now I can get a score, which is the accuracy score, which is another alternative of getting it. And now I can see, how well it's performing in the training set versus the testing set. And I see in this case that it's pretty similar. So what I'm doing in the training data is very well extrapolated to things that I have not seen, which means it's like good. If I see that the results of the score in my test data are terrible, means that my model is doing what we call overfitting. And overfitting means that I'm getting insight on my data that's only specific to that data set that I'm passing to the model, but it's not something that happens in the world, in like outside of that specific small data set that I have access to. So you might see, well, this is just one separation, right? I just split my data set once. 60% for testing, 60% for training, 40% for testing. But there might be some randomness in that split that I might be doing wrong. That just like by random, it happens that that test data that I chose is doing pretty well. And to avoid that, that's what we do with cross-validation, which means like now instead of doing that just once, we do that in like many times, and you can choose how many times you want to do it. Sometimes it's like 5 cross-fold validation, or 10. It's usually like kind of the standard. And now by doing this several times and getting the average, that accuracy it can be more, can be a better prediction on how well my model can perform overall, because it's just like no longer just randomly of a split that works well for me or that does not work for me, but that when I do it several times and I get the average, I can kind of take that randomness away of that accuracy is actually real. And that's implemented in what's called cross-validation score. And now I pass to the cross-validation score, I pass my model, I pass the X, I pass the Y, and now I pass how many times I want to repeat these. In this case, I did it 5 times, so now I get 5 different accuracy, and I can take now the average of those to get like my final thing. This is like how well I think my model is going to perform out in the wild. So I'm going to pass. So you can try and do the next one, just like from the previous model. Instead of doing whatever you did, the same, you can use the same model. Instead of just like doing the normal without splitting it in training and testing, now repeat the same flow, but using it this time. And then we're going to move to like another like review and example from Andy. If anyone has questions, you can like raise your hand, or troubles for figuring out what to do.
Awesome. So I'm told that we have actually till 12:20. Is that it? Everyone's, yeah, okay. Sometimes people tell me, oh yeah, you have plenty of time. And I was once a college professor, so you have to put time limits on how long I'll talk. Because one thing about college professors, we love our voice. Oh no, where'd it go? My computer dead? Oh no. Okay. All right, cool. So so right now we've looked at the where's my, there we go. So we've looked at how to get your data, how to load your data, how to manipulate your data, how to play around with it, and typically you're going to have to manipulate that data quite a bit to get something that you want to learn from. We've learned how to explore it visually a little bit, and we've learned how to basically build a basic model. And so these examples were kind of like me doing that on like in a kind of a single place. And so these are intended to be fully worked through examples. And so what I thought I would do for the last 20 minutes, our goal, so we have, I guess we could do one of two things. We left the last 20 minutes in our proposal to like let people group up and do this together, or I can take the last 20 minutes and go through in depth one of these pieces. So how many people want to like go try this themselves with a group? 1, 3. Oh man. Okay, you guys leave. No, sorry. So what we can do, definitely like like I'll go through the Boston housing data version, and then maybe like in an open sprint or something else, like people can get together. Like we have Google Docs coordinate, and we could build up different pieces, and you could change up. Now this is modeling. There's no one right answer. Like what I've done doesn't mean that that's exactly what you should do, or that it's going to be exactly right everywhere. So yeah, so I'll go through this guy and just kind of think about examples here. And then, but definitely, we're here all week, so we can get together and talk about other things you can do. So first, let's take Boston housing data. So you can actually just call scikit-learn and get the Boston housing data just like you did with the iris, but I actually went and says, all right, let's go look at where it came from. So there's this archive of machine learning data sets from UCI. I think it's Irvine. But so basically what you get is you get this nice web page, maybe even an awesome picture, and it tells this came from StatLib library. Don't know what that is, but I assume it's something. And it gives you some ideas. Like in 1990, this data was donated, and all this like machine learning repository is professors and students and academics contributing data sets to practice their algorithms on. And so there's all over, like you can look at the, like why people made these things. You can see how the creator is. And it's just like, housing values in the suburbs of Boston. And you can even go read papers, right? So the reason academics often do this is so that they publish their analysis, but then you can cite their papers. And so if you are an academic and you do use these things, please cite these papers and things like that. So that's how academics get paid to do this. Awesome. So what we have here is we have a data set that has these labels. And so lots of data sets come from like good old Fortran days where you can't use big names. So we have things like ZN, which means proportion of residential land zoned over lots of 25,000 square feet. All right, so I don't know a good variable name for that, but ZN is what it is. Okay. So when someone asks, what are the labels to iris? It's like, go read this page. And actually, if you look at it, it's iris is in here. Iris is from this set as well. So you can see the iris data set. And it gives a lot of information. And you can see it's very popular. Lots of people use this iris data set. Oh my goodness. So anyways, so that's where the data came from. Always very important to know where your data came from. So I look at these values. And the only thing that actually means anything to me is like age, number of rooms, median value. So I said, okay, how can we perhaps take this data, see if there's any, I usually assume a correlation between number of rooms, age, and how much something costs. At least that's the way, I bought a house recently, that's kind of how it worked, right? But I did used to live in Chicago, and I know crime is a big deal too. So not so big a deal in the suburbs of Austin, Texas, but bigger deal in Boston and Chicago. So that's our goal, is explore this a bit to build a classifier that uses these pieces. So here's all the imports I have, and it, bam, loads everything, okay? So in here we have our NumPy, pandas. We didn't talk about matplotlib and Seaborn, but these are kind of the basis of a lot of plots that came out early on, and so some static plots and whatnot. And then I get all my scikit-learn pieces. And then I actually didn't do the .star here. I thought it'd be really good and do all the pieces. And this is how you're supposed to do IPython widgets now, is you're actually supposed to do IPY widgets, although the HTML widget thing still works. But they're moving their evolution. So first thing I do is I make a column of those names, because the data set, if you go look at the data set, let's see here. Okay, so if I go try to look at this data set, it's actually like an old school format. Boston. And so they have like, this is how you see how it works. So you get a .data and a .names. And the .data is this. It's looks kind of like a CSV, but those aren't tabs. There's no token there. It's just like a formatted print statement. Good old C formatted print statement. So we're going to have to do a little work to get this data out. But you notice there's not like, a nice CSV usually has like the headers up front, right? And so this doesn't even have that. You look at .names and we have things out of here. So we've pulled these out and that sort of thing. So you get like R and Python and a lot of places, they actually pull all this out for you together, but that's no fun. That doesn't teach you anything. So let's go learn how to pull that out. So we name the columns, and let me just hit it. So shift enter. I hit, so what I have here is I say read CSV, and there's this beautiful little thing, separator. So if you actually go look at this thing, you see there's a lot of inputs to read CSV. And the separator is one that you can just give a pattern to. And if you read through all this bit here, you'll find that you can give it just a pattern. And so I say any space plus, right? So now I read that thing, and bam, I have a data frame out of it. All right. So that's first, got the data. Read the data, any questions? Got that, cool. Now from this data, we say describe this data. And so kind of just to learn, like what this does for me is it tells me if there's any like major problems with the data often. So you can kind of see here like this ZN, the zoning thing, is like almost all zeros. Like it's minimum 0, 25 percentile 0, 50th percentile 0, so the top 25% actually has some value to it. So like right away I can say there's an imbalance in that data. Like we were talking about the imbalance of the yes and no on the helpful reviews. So the describe helps me figure some of those things out really quickly. So that tells me those pieces. The ages is also a fun one here. Like you see a nice kind of distribution. But the thing about you can look at this or you can plot these pieces too. So that's kind of like get the notion of like what are your bounds of your data. And one thing, as you learn about more models, they actually do different things about scaling and things like that. So often some models, once you go to rescale your data from 0 to 1, and some models don't care. And so you have to kind of take that into consideration. So the first thing I do is like, all right, I understand crime, age, rooms, and median value. And so I did this thing called pair plot. So this is Seaborn. We didn't really show this tool very much, but it's basically got a bunch of statistical plots in it. They just call and it like produces interesting statistics. So this is let me take crime out for now, and so maybe I can see it better. So you run this guy. What it does is it computes the correlations between each pair. And so down here, like you have a distribution down the center. So my age here is the distribution. So I can see how I have a bunch of houses under 40 and then like, bam, a bunch that are above 110. So that distribution of age is kind of funky. Like you don't really have houses between 40 and 100 in this data set. Don't know what happened. Maybe someone knows the history of suburbs of Boston might be like, oh, there was a flood and everything died back, because Chicago, if you look at Chicago, you'd see like around 1910, there's no houses that aren't like older than 1910 because there's a great fire, right? So things like anomalies like that come out in here. The other thing you notice, all right, so age, so this is the column that if I want to try to predict median value, I have a somewhat nice Gaussian here. It's kind of there's a distribution here, very spiky, and then there's another distribution like up here. So this is probably the older houses, right? So I look here at my median value versus age. And so as my median value goes up, you can see the age is actually is kind of spreading out. So lower priced houses are much older for some reason. That's kind of interesting. And then it kind of spreads out, and there's like a clear drop off here, but that actually corresponds to the bulk of the data. So the bulk of your data is from this line to the left, right? So you can kind of give an idea here. You see that median value is best correlated with the number of rooms. So the number of rooms has a real clear correlation. So correlation effectively means the two things move together, right? So as median value goes up, so does the room, and the room number goes up. They both travel the same way. So these nice lines mean it's correlated. Whereas like kind of like spiky things, so there's some correlation up to a point with your median value and your age, but not after that. And so you can flip that around and say, as I get older, how does my median value change? As I get older, things get cheaper, or they get more expensive. There's a complete spread out. So it's not a very good indicator. Age is not a super great indicator sometimes. So I started this with crime. So instead of doing age, let's look at crime. Yep. So the point here is that there's some other variable happening. There's a descriptive or latent variable that you need to find to actually correlate these things together. And that's what the whole feature extraction piece is, right? And so the crime one I thought was interesting because most people zero crime. Like the crime index is 0 for most people, and there's a little bit here, like going out offward. So this actually tells us that, look, as your crime goes out, your median value drops precipitously. So it's definitely the case that it's not going to help us with all the data set, but that little piece of data it does happen with, it actually precipitously drops off. So crime is a really strong indicator that your price is dropping. And so, okay. Any questions about these graphs? Cool. So if I look at my housing data, here's the scatter plot. You can do the same thing with bouquet. So first off, I just start with can I get it to work? Yep. As you know, so you always have to do this. So now one thing you look at, so the quantile. So if I look at the 50th quantile, I can see what crime level is. It's like 0.25. And so maybe so what I did here is I colored by crime. So this is, all right, using quantile, I can tell what value is the value that I need to be less than. So I colored everything green. Then I took the top third, so the top third kind of lowest crime places, right? With the top third of the market there, and just colored. It said so I do a Boolean indexing here, and I say, all right, .log, I give it that Boolean index. I change the color to blue. So everything is blue is in that top third of the crime index. And the next bit here is I take the bottom third, the higher crime areas, and paint them red, right? And so then I add this to the scatter plot with my color, and I do some labels, and you can see here how red dominates over there. So we're actually seeing this kind of age versus median household, and how the crime rates kind of map to it as well. So there is some high crime rates where you do have a high median value. So these are the neighborhoods or whatnot. So it does happen that there are high crime rates, but the houses are something else is happening there. So doesn't explain everything, but you start looking at these pieces and you can understand kind of how these different crimes are going on. Here's actually adding the hover plot so I can see what's going on a little bit more. And what happens here with these hover plots, since there's so many data points, sometimes you get 2 over each other. So I have a high crime rate, but the piece here is these are these are houses with lots of rooms, 7-room house. So if you have a 7-room house that's dominating, even if you're in a high crime rate, you're still going to have a high median value. Whereas these guys are probably lower. Well, that's 5 rooms. So, well, that's interesting.
5 rooms, but less crime.
Yeah. Well, no. Yeah, you're right. So my buckets aren't fine enough in this example. So if you kind of make your buckets a little finer, you can get there. So we could actually do a whole a palette and whatnot. So something to kind of play around with there. So, and here's an example where what I wanted to do is play with the age range in that same plot of, well, it's not the same plot. This one I'm going to take and do the number of rooms. So we had some correlation between rooms and median household income. And so why don't we make something that lets us get through all of this? I'm just going to go say run all so everything runs and I don't have to worry about that piece. No. Oh, no. Oh, okay. Yeah, I changed the file locations, and I thought I got all the pieces there. So yeah, you have to add that dot there to make sure you get the file in the right spot. Okay, so here we're doing that same coloring, and we have a selector on just the age. And so here's my update function. And I show it the plot, and that's the first plot. And then this one, I used instead of using the decorator, I used it as the function, right, with the update function as the first one. And here I actually called out this int range slider, which is exactly what it sounds like. It's a slider that gives you a range. So I can play around this piece of data here. And I don't have the toolboxes here, but so immediately I come in here and I say from 25, like let's look at everything that's less than 20 years old. So it's a lot less data, but you can kind of see right away that building houses in the blue, most things are blue. We still have that kind of correlation between the room number and the median, the median household value. And so that's a pretty nice kind of like what kind of expected from those early things. So now if I take the next, as things move around, oh, you have to give the thing data. Whoops. Okay. So as you get older, there's a point which our assumptions kind of break down. I'm trying to find that point. So here we're adding blue. You also notice the crime index, like in this area, the crime isn't that, like most things the crime's not that high in that age. But as I get to older kind of places, you see crime start to like really pop its head. And you see like much the older communities, the crime, there's a lot of correlation with the crime and whatnot. So just taking these different pieces to put together, you see even these guys over here, which is like the rooms, like they kind of all line up here, but in this case the ages, it's not they're really old houses, but they kind of go the gambit. So age kind of trumps everything. So now I have an idea that how these pieces kind of correlate back and forth. We want to create a model and that comes and looks at, all right, can I, like, these different factors, understand a bit of the data, how do I create a model and pull out that data so that I can actually ask, all right, I have a crime value. I mean, I can't know all the things that are in that data set, right? And so this is one of the challenges when you're designing a model is like, I might have data on something, but can I predict with that data in the future, right? So I might be able, like I work in fashion, right? I might be able to take the measurement of your hip, but that doesn't mean that I can like just take a person and know what their hip is, right? So you have to like design a model so there are features that you can actually predict with. Which ends up being like the real art of data science often, is like getting those modeling pieces that are actually real pieces. And so in this case, I just kind of like did the full thing, right? Like let's pull in the data sets, and there's our target. And this is, we're just using cross-validation predict. So if I do everything right with like a 10, cross-validate by 10 bits, there, and I take my black box, my linear regression model, and so if I have everything, often I like to do this and say, I have all the data, how well can I do? And this is the matplotlib of the actual predictions. So here's the measured, so this is the confusion matrix when you have like a regression, right? So I have my measured value, my predicted value, and I really want to be on that dotted line, like, because that dotted line is exactly what it measures, what I predicted. And you can see like there's some spread there, but more or less it works, except, oh no, we're predicting negative values. So there is some cases here where our model is probably never gonna see a house that's just given away and we're gonna give you money to take this house. But so this is kind of like an indication of like, if you can't make cross-val predict work well, if you still get sloppy things, that gives you an idea that this model is never gonna do anything. It doesn't matter what I do, right? This is like the best I'm ever gonna get from my data, and I'm getting all the pieces there, but I'm still getting this kind of like variance, pretty high variance and whatnot. So that's how I evaluate that model. So we have like linear regression is just one regression algorithm. Let's reach into our black box and pull out another one. This one is probably one of the most used you see out in the wild, is like the random forest algorithm. Now, one thing I will say is like if you have a random forest algorithm out of scikit-learn, there's a lot of variables that go into making your random forest. And so it's not going to necessarily perform exactly the same as a random forest out of like another machine learning library like Weka or I forget what the other ones. Just Mallet, yeah, that's what I was thinking of. And some other places you can see these. So your mileage always varies. That's why you got to kind of do this test and kind of play with how things go. And one thing you notice straight away is the variance, like the width of that curve around there is much smaller. And so right away I can see that, hey, I'm not selling houses giving houses away for free. I still have this funkiness over here that I kind of clean. Like probably the next iteration of this is figuring out what this funkiness of like this line here is, cleaning it out. Maybe, often what you'll do is like say, I have something that's, all right, this piece of data fits in this bucket that's not really relevant, but this piece of the bulk of the data works well. And this is also a place where what you'll end up doing is calling these models in what's called a grid search. And there's an example in there of like doing a grid search of just setting the different values and choosing different models and see what they are. And so you can come out and like optimize this score number. And that's like the score, the higher score was definitely this, that second model, which was the random forest versus the linear regression. So going back and forth, we can put that in there. Are we time? Oh, okay. See, you got to tell the professor to shut up. The next step, which I was going to do with you guys, is to now like go back to those, like only go work on those pieces of the data we know we can get, like the crime, the age, the rooms, and things like that, and see if you can iterate and find out a model and fit and which model works best there. And then you can like serve the web app and say how much should your house cost and things like that. All right, thank you so much for your attention. We're around all week, so come talk to us.